So, hello everybody. So in this talk we will try to see a bit about dataset. We have like 3 different companies we see with 3 different usage of dataset, and we will see the state of the art on datasets, and if we have a bit of time, what's next and what will be the dataset in the future. So I will let them to introduce. So first, Agathe, can you introduce you and the company you're working for?
Hello everyone, so my name is Agathe Arlotti. I'm working for Owkin. So Owkin is an AI biotech, and the aim of the company is to better understand complex biology through AI model and to accelerate drug development and new diagnostic tools to accelerate and to better treat patients. So it's really for the beneficial impact on patients. My role at Owkin is to build relationship with healthcare institutions, so hospitals and research centers, to get access to their dataset. So I have a team of 30 people in Europe, in North America, dedicated to build relationship and build collaborative projects with hospitals to access to the relevant dataset for our projects.
Okay, Julien. Yeah.
So, hello everyone. Pleasure to join you today. I'm Julien Launay. I'm the CEO and founder at Adaptive. So we just got started a few weeks ago. We do reinforcement learning for large language model, which we package in a product that enables companies to perpetually improve their models. So we learn a lot from actual user interactions, so actual usage. And in the past, I've been part of the Falcon project, where we also built a very significant web dataset, Refined Web, where that time was kind of the opposite of the spectrum, where it was more like massive, very large-scale web data.
And Pablo?
Thank you. My name is Pablo Ducru. I'm one of the co-founders of Raive. Raive is a foundation AI company that does images and then video and other multimedia generation. And you can see us in this sense as a version of Midjourney or Stability. But we have in mind, how do you make this way more personal? And perhaps how do you respect more the IP, which is a core topic in the multimedia world?
So yeah, let's start. So you have 3 very different business cases. So maybe let's start with Agathe. What dataset are you using in your case?
So at Owkin, we access to real patient data. This is key for us to train the model with the data from patients. So what I mean by real patient data, it means patients from care, so that are routinely collected when patients are treated at hospitals, and also research data, so additional data from patients that are collected by researchers when they do their projects. On top of that, we are also generating additional data, like molecular data, genomic data, that are not collected through the classical care system. It's super important to reach the right level of depth for us in terms of the type of data we can get. So it means we have, in the end, multimodal data set, so clinical data, also histology data, which are slides from the pathologist that are obtained through samples when they do biopsies to do the diagnostic of the disease. And on top of that, molecular data, omic data, so RNA-seq data, DNA data, that can add a lot of information about the gene activation from patient.
Yeah. On our side, I mean, in the past, kind of gone through the entire spectrum. So, as you know, like large language models are typically trained on very large data sets that are essentially all the text you can shove at it. When they come out of that, they obviously don't really answer well to instructions. So the question at Adaptive is how we take them to actually interacting with users. And a lot of our thesis is that actually you can do this by learning from the actual interactions. So typically what we do, you know, if you think of a Copilot-like application, I think a lot of people in the room probably have used GitHub Copilot. Whenever you accept or not a suggestion, well, we can learn from that, and we can continuously learn to make the model better. So it's really going, you know, after that kind of like massive first phase where you're just trying to get to the model, the sense of the world, of our world. It's really getting it to, you know, being able to navigate that knowledge and give it to the user in the proper way.
So at Raive, the data that we're using right now, the first foundation model we're building is an image generation one, and then we're going to go into the video ones. Today, the present kind of open source model out there that's most famous is called the Lion dataset. The Lion dataset essentially scraped from the internet as much images as it could find. So it was about 5.6 billion images, of which only 2 billion are of good enough quality. However, they were not particularly selected for aesthetics purposes, nor were they, asked for, in terms of copyright, the rights to train on these. And this has actually produced some form of problems in terms of major lawsuits being carried out against OpenAI, against Midjourney, against Stability AI, from people who feel that they were not consulted and that this is infringing on their copyrights or other form of IP rights. So what we're doing at Raive is we're right now constituting our own proprietary dataset. We call it Raivium, with the goal of building the best multimedia dataset, both on image and video. And the way we're doing this is we're doing it in different approaches. We're first finding online what we can have access to in terms of license that we can pay for or that has the correct number of licenses. We're also going to essentially opening a new market, which is the market of licensing data for training. So this is something new. Usually the entire multimedia industry relies from licensing copyrights of certain images or videos and collecting royalties on these. Now it's a new form of royalties, a royalty for training, but without the distribution rights. So we're one of the pioneers in this field of how do we develop this new type of license for training.
Yeah, we'll come back on licenses later. So first, one of the important questions on dataset is how you ensure the quality of your dataset. And so because you have like 3 different usage, you have 3 different metrics for the quality. So yeah, how do you use that, and how do you prepare your dataset before sending it to the model to make sure you have the high level of quality?
So in our case, it's key for us to have the highest level of quality, so meaning data that are curated by clinicians at hospital level with the medical expertise. So we really need to collaborate closely with medical experts so they can create the dataset. They are the best ones to actually correct all the datasets. So it's a matter of how we collect the data to closely work with the hospitals. So if it's data that are collected from care, the first purpose is to treat patients. So they are not collected exactly the way we want to have them from an AI analysis. So we need to transform the data so that they can become AI ready. So it means they need to be curated, they need to be structured in another way, which was not the initial purpose. It requires a lot of efforts. Most of the time, hospitals are not ready to do these efforts, to have additional resources dedicated to that task. So we have our own team that build with the hospital the relevant expertise to do that. Then internally, we can also refine, standardize better, verified the way we need to do that to accelerate then the treatment for our data scientist team internally. We are also, most of the data we access to are retrospective data. So they have been collected for the last 10, 20 years sometimes, with lots of follow-up for patients, so a high quantity of data, which will require a lot of curation to simplify and to standardize. Now we are also starting to collect prospectively the data, which allow us to create exactly case report form, so ECRF, as we call them, to exactly collect the data at the relevant format and make sure the clinical research assistant will help us to collect the data the way we want to have access to them, which is key. It's essential. It means we have to build this way of collection at the beginning of the process to make sure we will have the relevant level of quality in the end. We can, if we access to random data, there is a high chance we will not get to the high level of performance we are required for, or when we want to validate the model, we'll have some, I would say, questions, so we will need to re-access to other dataset to confirm the results. So I would say anticipating the collection is key for us, and closely work with hospital is a very good way to do that.
Yeah, I think it's different sides of the same coin. Data quality is an issue everywhere. So for large language model, typically, I think there's a component of you cannot be too picky. I think that's a big difference, especially in pre-training. You need tens of trillions of tokens to train a modern large language model. And there is only so many of them in the world. So at some point, you have to accept some bulk effects. However, there are some, I think what's very interesting with large language model is that the way they perceive quality in a way, in like what gets you better, and performance is very different from what you would expect. So for instance, in Falcon, we found that deduplication was perhaps like the strongest, essentially, factor in data quality. So simply running deduplication, which you can do at very large scale, and deduplication you can do in a way that's completely agnostic to the underlying content of the data, like Minash or that kind of stuff. You don't even really know what's underlying. And this gives you very good results. So there are certainly some aspects of that, but then obviously there is some stuff where you need to go a bit more, hands-on, and that includes artifacts, for instance, when you run a web crawler, getting, what's the actual content and what's the boilerplate, what are the ads, that you don't want in. And even further to that, in the late stage specialization of the model, which is here, you start to see the influence of very individual data sample of the diversity. I think you see it recently with the Phi1 project from Microsoft and Phi2 actually, which was announced, I think yesterday, where you see essentially that by having data that's like textbook data or fake textbook data in that case, since it's generated, you gain a huge uplift in quality. And I think there is a lot of this, like right now on large language models, there's a lot of cool stuff in that direction, and kind of also that last mile of data that you can add on top of pre-training, which can take you in completely new direction with very few samples. And that's a really exciting direction.
Yeah, what we're doing at Raive with the foundation model for image generation, when you're doing a text-to-image model, what you're doing is you're combining two different versions or ways of describing a concept. So if you have a cat and then you describe it as a cat, there's a linguistic form and then there's a visual form. And these two aspects of the data matter a lot, and the way you combine them matters a lot, and sometimes in ways that are unintuitive. In general, for foundation models, more is better. That's what Julien was saying here. However, if I'll give a simple example, more cats that are low-quality cats will actually help you do bad-looking cats. And so sometimes more is not better. It's a regression to the average. So if what you want here is better-looking outputs, prettier images, more cinematic perhaps, you'll have to be very selective, as the adage goes, garbage in, garbage out in terms of training. So you really need to have a real selection of the visual universe that you're putting. So that's the first aspect, and that's one of the reasons why when we're building the Raivium dataset at Raive, we want to work as much as possible with the best sources. So we want to work with the studios, with the stock media companies and so on, so that we have the highest quality data in terms of visual aesthetics and representation. Another aspect is the breadth. So I think a good example here is Adobe's Firefly. So Adobe has been an answer, if you want, from the industry to Midjourney or Stability AI that have been a bit considered like the pirates who came in and took everything they could from internet. So Adobe said, well, I have a large corpus of stock media. I'm going to train only on that. The problem is then it becomes kind of culturally poor. It doesn't know anything other than stock media and cannot generate something that looks outside of the stock media. So the challenge of generating a model that is both respectful of intellectual property, but at the same time has a knowledge breadth that goes beyond stock media is one of the core challenges that we're tackling at Raive, and requires, as I said, a very careful selection of the way you take the visual representations. Now, there's a second aspect to this, which is the annotation one. I think an interesting viewpoint here is the difference between DALL-E 2 and DALL-E 3 is mostly from the annotation of the image and how much you describe it with details. If you say someone walking the streets of Paris, or you're very precise on how there's a light coming and so on, it's the same image. And however, the way you fuse, as we said, the textual world and the visual representation of them really can give way more powerful results at generation. So those are the two aspects that we're working on Raive.
Yeah, great. So we are talking also to get a better quality about multimodal. So I think you all use multimodal now. It's a new trend, like to push the boundary of the data set. So how do you implement it within your company, and what advantage multimodal give to you?
So in healthcare, it's really the depth of the data we can access. So we started with, so Owkin started initially with histology, So really looking at the slides and being able to, through the annotation, we have exactly the same need on that, to try to better describe and better characterize the disease using pathology slide. Of course, to do that, you need to have the clinical information, so the demographic characteristic of the patient, but also all the information on the treatment, the survival impact, so all the follow-up I was mentioning earlier. And then if you want to better understand the biology mechanism behind that, basically you need to deep dive behind the image. So you need to access to the gene information. So this is why we added this level of information, which was also going with the trend in all research projects to access to new technologies and new information. So single cell data, spatial transcriptomic data, we can add a lot of information and will allow to really accelerate the type of research. So in our case, it means opening really the door to a better personalized medicine, to be able through large population to subtype the population and identify a subpopulation in which a mechanism is expressed differently, which will better target the new molecule we try to develop. So this is what multimodal dataset allow us to accelerate and do better in our case.
Yeah, I think on the large language model side, it's still much more boring and much less mature than you described. We are very far from having that melting pot of different modalities that learn essentially from one another and that inform each other. I think it's kind of funny. One of the big reasons I think a lot of like big frontier labs now are looking into multimodality beyond, it's cool to have a model that can understand images. It simplifies like for some tasks. It's very valuable. I think there is also a question of the amount of data available, very plainly speaking, which is that in terms of text, we are kind of not quite running out. It's a bit of a strong word, but we are reaching essentially the limits of high quality text we can shove into a model, and probably the next generation of model will be there, essentially, more or less. And so I think there's a big gold rush, essentially, in knowing, can we find another modality that will inform, that will bring new information to the model and genuine new information. And it's not as obvious as it seems. I think, as humans, we think, vision is like, for instance, a fundamental component of our life and of how we interface with the world. But it seems for models, it's a bit different, and it's not so obvious. Obviously, they have an advantage. I've seen pretty much all of the text that we have ever produced. You have to imagine amounts to quite a bit of knowledge. But I think this is a very interesting question, and it's kind of like a $10 billion, $100 billion question right now of how you can get true multimodality, not just putting the modalities next to one another and kind of, like hooking them up and hoping for the best, but really getting them to benefit one another, so like a joint multimodality. And there's lots of exciting work on like the chameleon architecture, that kind of stuff, where it's really exciting to see like when it will scale up and what it will give in terms of like scaling laws and like is image data, like how many words is worth an image, essentially. That's kind of what you can quantify. And so far, it seems to be a very complicated topic, but this is definitely, I think, what we are going to see in the coming years, and it's a very exciting perspective.
So as Julien says, we'll see whether an image is worth 1,000 words or not. The thing with multimodality is, unlike text that is a consistent world, so you just need to train on yourself to understand language. Language describes another part of the world, that's the reality around us, which is actually why we've called our foundation models at Raive reality. So it's reality 0, reality 1 coming next year. The multimodality is just intrinsic to the way you cannot just describe an image without the language here. So you're already multimodal by definition when you're doing text to image. But if you only learn from images alone, for instance, you think the world is 2D. How do you know that this object is in front and that object is behind and so on? So today, a way, for instance, to improve the controllability of generation, and if you want to do some, editing of images, for instance, some interesting data that you can add to control this would be the depth map. So there has been, for instance, deep neural networks that can extract some form of a depth map. So we call this 2.5D. They cannot learn this from images alone. So you already have to be multimodal to teach to teach the architecture here, the foundation model, that, hey, there is depth. So perhaps you could go on video and extract that just as we do. If we cannot move around or we had two eyes, we cannot extract the depth. So this is, I think, in general, the point of multimodality is the image of the elephant, right? So you come here and you touch the foot or the back or the trunk, but the whole thing is an elephant, and you cannot describe it with only one of the modalities. And the more you add, the better understanding you get of the fact that what you have in front of you is an elephant. So that is ultimately why, even going into video generation, we're already seeing that it's going to be very hard to get some consistency over time with a flow and motion if you cannot have all these type of modalities that represent these different types or aspects of the elephant.
That comes to the next question. So now you have the great data set with valuable data. How do you keep this quality through the time? That's a big question. How do you iterate with your model to get to the lower quality? We see with ChatGPT sometimes when you go to a new version, you don't get the same quality on some questions. So how do you give the best to your user through the time?
For us, it's a difficult question. I would say it means because in healthcare, so it's very difficult to enrich again a data set. So there is the whole question of the identification of the patient, which had a lot of limitation. So if we access to anonymized data, you can't go back to the patient ID, which means for an hospital, they will not be able to add any data. So maybe with new version, you will add new questions. So you will have a new scientific information you will need to explain some aspect of the model. If you have an anonymized data set, you can't do that. If it's a pseudonymized data set, which means there is still an access to the patient information, you will have to make sure you have patient consent to access to this level of information and to confirm the purpose of the research project you're doing or of the new model you're developing is accepted by the patient. So this is a huge limitation in healthcare, which means from ethical and regulatory point of view, we will need to check that is feasible. So it's a lot of efforts at the moment. It requires a very good understanding of the law, the different type of how it's applied within Europe, within US, etc., and really get the opportunity to do that. So for us, it's a critical point. On top of that, it's also accessing external dataset or other dataset to really validate, make sure it's a common question. The small population you have trained your model on, because most of the time they are too small for the point we mentioned, will get a validation on others, which will lead to the same type of question. You validate on another dataset, you will raise another question, and can you train again differently? And we are in this loop a lot of time, which means how from the beginning we try to have access to the most, in terms of depth, the highest number of data. But again, for ethical question, we need to get this approved. And from an ethical committee, from an ethical standpoint, it's still an open question. Today, can we access to data we're not sure to use? So there is a question for patient. Do we have to raise this question? Can we access to data we're not going to use? It's still an important point.
Yeah, I think generally this is, and I think this relates a bit to what you say, there's a question of maturity in how we approach our models. And I think actually probably more classic models like the one you deal with are at a higher level of maturity than large language models. The way people currently approach a large language model is very static. It's like, oh, I get this model probably for Hugging Face, I do a quick fine-tuning job on it, and that's it. And then it will stay in production for 1 year. Maybe when Llama 3 comes out, I will update, but once again, I will just spend a month with my engineer working on it. So a lot of the work we do, for instance, at Adaptive ML is getting to another level of maturity where the model gets essentially continuously improved, like learning from every interaction that you see. And this goes with a lot of very classic things, actually, in the industry, like A/B testing, that kind of stuff, where really you measure, really the impact that as your update on new version of the models. And we don't see that much in the industry, actually. I was in the US a few weeks ago talking to a bunch of people using GenAI in production, and a vast majority of people don't A/B test, for instance, which is a bit astonishing maybe to some of you, but this is something that's very new. And there is a lot of work, I think, to be done in terms of going to that level of maturity where, okay, our deployments are going to be more dynamic, they are going to be learning continuously, we are going to be sure that they are going the right way and not, the wrong way. And that's quite a big challenge. Where I think we are kind of lucky in all of this is that large language models are very unique, and probably by their size, in their ability to both, learn from very few samples. So sometimes with just a few, with like 10 demonstrations, you can radically change the behavior of a model to something new desire. And on the opposite end of that, with 1 million demonstrations, you can still, inch out essentially more and more understanding from this 1 million of demonstration. And this is probably the most impressive and most unique capabilities of the model we are dealing with, which is they address both ends of the spectrum. Both, like very efficient learning from few samples and also massive learning of very nuanced like perceptions and from a very, very large amount of data. And that's probably the perspective of them that makes them the most exciting.
So how do you keep the quality, or maintain the quality of a data set? I think there's 3 components that are very important when you look at the multimodality of text and image, and how do you combine these two. The first one is that an annotation, as we said, is key, but also can get old. So, and you can even see that in text too, by the way. If you were to read a newspaper from a century ago, it really reads quite differently than today, and even just 50 years ago. And the same goes because the language evolves, but also the places around you evolve. So the same picture would be described differently at different times, and also in different cultural places and areas of the world. And so that mapping, you have to keep up to date. If you don't continuously do that, you grow stale in terms of your descriptive power of the world. The second component is how do you keep updated live? And so that's the same point that Julien was saying is, especially in the media world, there's always these, novel things happening, right? Taylor Swift just went through one of the most successful concerts in history. That's part of what's happening today. If we were to have trained the model only a year ago, this doesn't exist in the model in any form or fashion. It doesn't have the knowledge of it. It doesn't have the imagery of it. So this type of things, of how do you keep it up to date, is also one of the reasons why we're approaching this with the constitution of the Raive training data set, whereby we want to go and engage with all the actors that have access to these live images, media, and tell them, let's continuously feed the model, and against of which you'll get a percentage of the revenues that we generate with this. And so that helps us keep the model and maintain it up to date and live. And I think the last one that is important is due to the volume. A lot of the systems today, for instance, Midjourney, that's pretty much the preferred model out there, and they've done a fantastic job. One of the things that they've done, or though it's not public, everybody knows, they've bootstrapped a lot of the data on things that they've trained themselves. And that is not surprising, given that the numbers that we're seeing today, especially in the music business, the number of AI-generated content is increasing exponentially, actually faster than what the rest of the world is happening. And if you take this trend in 5 years, it's quite likely that most of the content in the world will be AI-generated. Which is not a surprise, I feel, because you don't have to be restricted to what you see. You can also just imagine things and generate those. And that's one of the big ideas behind Raive. Give this camera for your mind to everyone. But that also has a problem, which is if I just continuously train on the data that I have generated myself, am I not just feeding my model with what it already knows? And we're already kind of seeing this, for instance, with Midjourney, where you see an image and you say, that's a Midjourney image. It has kind of this style of its own. How do you keep the breadth of it? How do you keep more style coming in? How do you enlarge the model and not actually narrow it down? Is an open question when it comes to bootstrapping on the data you've generated yourself. So that's an important point too.
I think it was actually bouncing up on this. There is a lot of interesting stuff right now where there is this risk of mode collapse that you see sometime where a model just trained kind of in a dumb way on its own outputs will just like collapse further into this like degenerate style. But you also see the opposite trend with stuff like constitutional AI or RLIF, where models are also capable to self-annotate and to bootstrap themselves out of of their previous of what they were doing previously, like into new territories. And it's kind of like it seems scale has a huge effect to this. Like it seems that larger models are more able to take advantage of their own annotations or to create annotations that are relevant. But it's very interesting to see where this is going, because this is Anthropic pushes a lot on this, and it's one of the reasons Claude has that feel to it. And it will be very interesting to see that, like, if we can go beyond, like just degenerating and just always generating the same stuff, because, they will just learn from, or we'll have a hard time filtering out of the web data or the image data what was generated, or if we can actually use that for our advantage.
Yes, sure. So before having AI everywhere, as you were saying, there is this hot topic about regulation. There was talk a lot about this morning on these points. So you have different domains, so different regulation, but on health data, its regulation have been there for a long time. How is it evolving today?
Yes, so in France and Europe, it's GDPR that is applied to access patient data. So as I was mentioning, to really protect the patient rights, to make sure they have provided their consent, that the purpose of the way the data are used is really clear for them and that they have agreed. So they always need to have the opportunity to opt out for the project, so we need to make sure of that. So that's a constant concern. I think we can say realistically today that it's slowing down a lot of research projects. So we need to, and I think from a political standpoint, a lot of efforts are done at the moment at the European scale, but also in France, to try to revisit how GDPR can be better applied to healthcare and at the same time protect the patient, but still allow us to better innovate in a quicker manner. So trying to broaden a bit the spectrum of what is feasible in the benefit of patient. And I'm always saying that if you ask a patient whether or not they agree to get access to the data for research purposes, most of them, 90% of them accept that. So we need also to revisit the way we collect consent to make sure data are more easily accessible and can be accessed for AI models. There are a lot to explain, of course, to teach patients when it's done by their practitioners, their clinicians, that they can trust when we have clinicians that are also very open to what AI can bring in terms of discovering new type of treatments. I think it works really well. Of course, there are some profile of patients that will always be against giving access to their data, but it's very few of them in the end.
Yeah, I think on this it's like for obviously for anything related to like pre-training and all of that, I will skip a bit that. I think it's a subject that's very difficult. Is it fair use? Is it not? How do you deal with that? And I'm sure actually you will have a very interesting perspective to bring on this. But on the last mile of data, I think this is actually where you can be a bit like what you mentioned. You can be very user friendly essentially. Of like, do you want your data to be used? And I think we have a responsibility of clarity, like how is your data going to be? Is my data going to be used just to make the model better for me or for multiple users and all of that? I think it's like, this is something people where I think if we inform them, there will be a bit less of a panic, around what is going on with this. And typically, I think another interesting perspective on this is just the model bootstrapping themselves, because eventually, if the model are able to provide the bulk, of the annotations, we have much less to rely on essentially humans where we are unsure about their consent. For the model, the consent, well, it gives it. It's happy to give it. So I think it's like on the last mile of data, there is right now a lot of exciting stuff that can be done in this regard. But for pre-training, I think it's very difficult, and especially in images, I'm sure it's especially a hot topic nowadays.
Yeah, I think, Julien, you're spot on here. There's a couple of questions that are really important here. Well, first, we should not stop the speed of knowledge here. It's only been a year and a half since DALL-E 2 came out, which is kind of the first real image diffusion model of high quality that really has said, okay, let's change. It's changing the world. Should we really stop that just within a year and a half? So probably not. And actually, some countries have already taken a position on that. So, for instance, in Japan and in Israel, they said if it's for research purposes, it is fair use. Now, if it's for commercial application, it changed everything. And I think that's where it's quite interesting for where we land in this landscape between you, Agathe, and Julien, is we don't have very sensitive data. When you're in the image world that we're dealing with, it's entertainment, it's aesthetics, it's not medical, it's not sensitive. So it's not that of much of a privacy or concern. However, it can have commercial value, right? So if you're dealing with an image of, I don't know, Beyonce, she has the rights to publicity, there's her likeness, and so on and so forth. How do you deal with that? Now, there's two key core issues here. The first one is whether or not training a foundation model in and of itself is a fair use of, the way you collected the data, essentially a copyright. I'm talking right now a lot about US regulation because we've worked a lot on that. Actually, we went through every single copyright court case in the history of US and started analyzing these and whether or not you can measure whether something has sufficient transformation or not to be or not within a fair use context. And that's a very hard concept because copyright is way more different than something easy like trademark, identifiable, or likeness that's very identifiable. But regardless of that, whether or not it's the training in and of itself is fair use or not, and it's up to the courts right now to decide. There's, as you said, an approach to this that could be way more win-win, saying, hey, if we're looking for the best quality data, for the live data, also annotation may be important and so on, there might be, and there is now, an emerging market for paying for training, even if it happened to be fair use. It may have value to have better quality data, easier to access and so on. And we've seen that already happen. So for instance, giants like Meta have gone to giants of the stock media companies and say, hey, I'll pay to train on your catalog upfront, here it is. There's actually, so it's a very new market. We're part of that market to some extent. What does the price go to, especially if the courts end up ruling that it's zero? It's an interesting one. Well, meaning if it's fair use, is the price going to go to zero? So that's for the training. However, there's a second question that's very different, which is the outputs of the model. Now, regardless of how you do it, you don't need AI. You can just Photoshop and do a collage. You can very easily create an image, of, let's say, Beyoncé that is infringing on her rights. And so that is a different question than the AI question. And I think one of the problems that we have today is the only solutions that have been proposed really out there, or not many solutions out there, have been proposed that are constructive. What I mean is either you do a Adobe Firefly approach where you're kind of ignorant, or you forbid. So you say, hey, this is against the content policy. There is a way that Apple has come out, and that's what we're doing at Raive, to kind of create a knowledge breadth, but that has no clear IP attribution. So you kind of anonymize at the moment of annotation, such that if you ask for Beyoncé, it doesn't know that there's Beyoncé, but it has actually learned the likeness of an artist and a star. However, how do you make a system where the artist can profit and benefit from this AI revolution, saying, actually, this is my AI, and I want to publish it and start essentially making money and getting royalties out of this. I think a great example here is in the music business. There was the Drake song that came out about 6 months ago. And it really was kind of a revolution there. There's no official Drake AIs yet. Now there is one that's being done here with Grimes, for instance. I wish every artist were able to have an AI that they could publish and start making standard remixes as part of culture and make money out of this in a natural and friendly fashion. And that's kind of the system and the infrastructure we're building at Raive.
Okay, so we have 2 minutes left. So. Agathe or Julien, do you want to add something on what's next on the data set? Do you see like something coming new? I think on Raive you are already on the future, but yeah.
So I would say for us in healthcare, it's larger initiative that will allow us to access larger data sets in terms of number of patients and worldwide initiative that can get us access to much more multimodal data sets. So at Owkin, we are aiming to contribute to that. So also doing our own initiative, which is called Mosaic, to work with 5 European and North American centers to create our data set and try to contribute also to that. But it has to be a joint effort with a public initiative, private one, to really accelerate the creation of multimodal data set, multi-centric approach, and also with the acceleration of omic modalities, which are key to develop new models. You mentioned LLM for healthcare, so it's the next step also, and to make sure we have specialized model with the high quality data sets.
Yeah, I think we will, essentially the next step is that we will see both extreme end of the spectrum. So on the pre-training, we will see essentially accumulating pretty much any form of data. Like as soon as we can find ways to encode, to tokenize, healthcare data efficiently, to have like a true joint distribution, we will see that. I think we'll just like gargle up everything that we can feed into the model. That works very well. So I think it will keep going. And on the other hand, at the later stage, I think we will see, and it's what we are doing at Adaptive ML, but we will see extreme personalization. So I think we will see, with every interaction, the model will distill down knowledge down to the user level, essentially. Not just learning for everyone, but model that become hyper-specialized, that know, you very in depth, that know what you want very in depth, and that will be kind of an extension of you. And I think we will see really the both extreme of the spectrum being explored in the future generations of LLMs.
So great. Thank you, everybody. I think it's time. We can talk all the day about models and data, but yeah, we have to finish and to the next panel. So thank you all for the...
Thank you.
Thank you very much.
Thank you.